see a lot of people has joined this room. I really appreciate it. And I'm Dr. Golnar Rahmetullah, and like this is my first time being at SOAR 2025, and I really enjoyed all the presentations, really great work. So before I dive in, I want to briefly share that my research focuses on designing technology that's more inclusive, especially for people with visual impairments, motor impairments, who are often get overlooked by mainstream interfaces designs that we have nowadays. And today I'll share how inclusive design can make and try to make everyday interactions more intuitive and accessible for everyone, including people that I mentioned. So let me start with something really simple. If you can't type, you can't really participate in modern life, right? Think about how often we type, whether it's replying to messages, finishing homework, checking your healthcare information, or I don't know, even the ordering right,
Dr. Gilner?
Hello?
Dr. Gilner? Dr. Gilner?
There's something wrong with
Can you hear me now?
Yes.
Yeah.
Yeah.
Where can you tell me when did you lose me so I can pretty much from the beginning or
from the purpose?
From the beginning.
Yes.
From the beginning.
From the beginning.
No. We heard
not there.
Yeah.
Oh, okay,
from
okay.
the slide, the purpose as you yeah.
Okay. So I mean, I was just talking about that typing is really essential, and if you can't type, you can't really. You can't really. Excuse me. Is everything okay?
Yeah, it's just some people need to please make sure to mute your microphones. Thank you.
Okay, so typing is really essential. We type everywhere for pretty much all of our tasks. We even and most of this typing we do it on mobile devices like phones, tablets, and smartwatches. So here's the catch. Most of these devices were designed with a very narrow users in mind, right? Someone who can see clearly, tap tiny buttons on these devices. They need to be quick, and they should also have this kind of full motor control, right? And now imagine trying to use them if you're blind or if you have limited movement in your hands, fingers. Typing suddenly becomes slow, frustrating, or even impossible, right? And this isn't a small group of people I'm talking about right now, because we're talking about millions around the world living with a permanent visual or motor impairments who still don't have equal access to one of the most basic ways of interacting with technology. That's what led my research, because if we can make typing more accessible, we open the door to everything else like communication, education, employment, and independence, right? So the main purpose of my research is very simple: to make typing accessible on mobile devices, particularly for blind, low vision, and people with motor impairments. So now that we've seen, with this slide, I wanted to explain you why typing is essential and how it impacts our everyday life. And now that you've seen that it's such central part of everyday life, let's step back and ask, how do we make sure everyone can type as, useful as we do, right? So everyone have equal access. The answer starts with inclusive design. And let me quickly you might be thinking, what is inclusive design? Or if you know, that's really great. Inclusive design simply means creating technology that works for all people, for, full range of human diversity, not just those who can see perfectly or move easily, but also people who are blind, have low vision, have limited dexterity, or just, can use technology in different ways, right? And here's the part often surprises people. Disability isn't rare. It's actually quite common if you think about it. It can be something you're born with, which is called permanent impairment, something that develops as you age, or something that happens suddenly because of, I don't know, illness or injury, right? We're really talking about millions and millions of people, of users worldwide, right? And when we design with those users in mind, something interesting happens. We don't just make technology more accessible, we make it better for everyone. The great example would be like, take captions, for example, right? They were originally created for people who are deaf or hard of hearing, but today we all use them. I mean, I use it myself in waiting rooms, on social media, or when watching some kind of videos without sound, right? The big idea here is simple. Inclusion isn't something we add on later, like after we develop the main thing and we're just started thinking about, hey, how about these users? Inclusion is something where with what we start our design. So that's the big idea here. So let's take a closer look at the tools people are supposed to use for typing nowadays and why they don't quite work for people with impairments as we'd hope to. So first one is TalkBack on Android or VoiceOver on iOS. I don't know if you ever heard it or used it. So basically those are just built-in screen readers that we have on our devices. On paper, everything sounds promising. You slide your finger around the screen, it reads out the letters, and you just double tap to select it. But in practice, to be honest, it's painfully slow. I mean, like, I don't know if you ever tried it, but every letter takes multiple steps. I mean, like, for example, on the screen, you can see the picture, the lower picture. It shows that person is trying to enter letter Y, and in order to do that, he swipes his fingers multiple times until he reaches that letter, and then he needs to do double tap. And imagine if this letter, I don't know, at the bottom row somewhere at the end, right? It's going to take forever him to, I mean, like, just to enter one letter. So the other thing that with this types of solution, you have to memorize gestures, and if your finger for some reason flips, you have to start all over again. It's a nightmare. And then there is a speech input. You might say, hey, but there is speech input nowadays, right? Why we don't just use the voice typing or Siri? But it sounds convenient, right? But only if you are in a really quiet space, you're speaking clearly and not worried about your privacy, right? Because some people, I mean, like, they just don't want to say out loud their private things. So, for example, password, right? Or if you try using this voice input in, I don't know, some noisy bus in a waiting room, or your voice for some reason shakes, or you have some kind of accent, suddenly it's not so reliable, believe me. And finally, there is QWERTY keyboard that we are very familiar with, right? This regular QWERTY keyboard, the one we all know on the touch screens. So the tricky thing here is that on the phones, on tablets, we have it, but it was originally designed for typewriters. I'm not going to go into really like history of it, but it was designed for to make sure that keys are not jammed. So it was designed hundreds of years ago. It's really never been updated for our phones. It's never been updated for touchscreens, and definitely not been updated for users with disabilities. So if you can't see well, if you have trouble with fine motor control, those tiny keys can turn typing into daily nightmare. So the takeaway is simple. The tools we have right now weren't built with accessibility in mind. That's what I think the biggest motivation for me was to explore new designs. So let's talk about the study setup. We worked with just a quick formal things. We worked with representative users, people who are blind, have low vision, or have limited dexterity, motor impairment. So the goal was to make sure our designs were informed by real experiences, not our assumptions. For data collection, participants completed text entry tasks on both mobile and wearable devices, basically depending on the system we were currently testing. Afterwards, they filled out short surveys and joined interviews to share what they felt easy, what was frustrating, and what they would want to improve. We measured basically three main things here. The first one is performance, meaning typing speed and error rate, how fast and how accurate users were. We also measured some other metrics, but those are the main ones. Then we also measured usability, which included how easy it was to learn, their preferences, and how much mental or physical effort it took for them to complete the task. And finally, experience, capturing their overall satisfaction, frustration levels, and whether they would actually want to use the system in the long term, you know. For the analysis, we used mixed method approach, combining both quantitative data, like, as I said, words per minute, error rate, and qualitative feedback from users, stories, and comments. I guess we usually, in our HCI field, in human computer interaction field, we usually use this mixed method, both using qualitative and quantitative approach, because I guess it just gives us more explanation statistically, right? But we understand why it worked or why it didn't work from the user's point of view, right? So it's kind of complement each other, the quantitative analysis and qualitative analysis. Okay, so after studying how current tools fall short, and I guess now you kind of have some kind of understanding why current tools doesn't work for people with impairments, that brings up our first project called Senorita. This work was presented at our top conference called CHI 2020 in 2020 in Hawaii. And it grew out of the real frustrations we heard from blind and low vision users who struggled with traditional input methods. So basically, Senorita is a two-thumb corded keyboard designed to make typing faster, easier, and more intuitive for people who can't rely on visual feedback. But what really makes it special isn't just the technology, is that what I want to emphasize here is the process behind it. Okay, so every stage from early sketches on working prototypes was co-designed, tested, evaluated with blind users, okay? Because they gave us feedback on layout, on gestures, on sounds. So we started with blind people to develop something for them with them. That's, I think, the main difference of our projects from most other projects. So let me introduce you Senorita, a mobile keyboard we designed specifically for blind and low vision users. The idea behind is actually pretty simple. So instead of squeezing 26 tiny letters onto touchscreen like regular QWERTY keyboards, Senorita gives you just 8 large keys arranged in a single row, 4 on the left, for your left thumb, and 4 on the right side for your right thumb. Now here's where it gets interesting. The 8 most frequent English letters, which is E, A, I, S, R, N, O, and T, can be typed with a single tap on it. No swiping around, no double tapping. To type the rest of the alphabet, you simply press 2 keys at the same time, one with each thumb. We call it QWERT. For example, to type H, as you can see on a video, you tap 2 keys that corresponds to that letter combination, which is T and E. And once you press T and E together, you'll enter H. So over time, users don't need to rely on audio feedback for every letter like they do with regular keyboards. I mean, like blind people. Their finger starts to remember the combination, almost like your hands learn the notes on the piano. I don't know if you ever played any kind of musical instrument. That should make sense to you, because we're basically applying the same knowledge here. It's like playing musical instrument, either guitar or piano. And here's the fun detail. The name Senorita is actually an anagram of those 8 most common letters. And but the part I'm, again, most proud isn't layout or fun naming, which I really like. It's the way we built it. We didn't just design the keyboard and hand it off. We worked side by side with blind users from beginning through the stage of design and testing. So basically, here's the evaluation. I think you kind of got the idea of the keyboard, how it works. That's why I included the video. And here I'm showing you our real user study. We tested Señorita with 11 participants who had visual impairments. Some were blind, others had, some kind of light perception or low vision. And the results, honestly, they surprised even us, because the first major finding was that blind users typed 32% faster with our method, Señorita, compared to the standard QWERTY keyboard, which is extremely huge for us. That's not just a small improvement, it's a really breakthrough, especially considering that, as I told you, QWERTY has been the default typing system for more than, 100 years. And this result really enforces one key idea. When we step back and rethink the design from ground up, rather than trying to, tweak this existing tools, we can create something truly powerful and that truly meets people's needs, I would say. So let's just talk a little bit numbers with Señorita users.
Dr. Goldner, I apologize. We're out of time for the presentation. If we could
still
move
got a few minutes, Dr. Meyer. I was thinking the same. This one ends 10 past. Am I wrong?
It says 8:02 to start Q&A.
Oh, okay.
But if she wants to continue, and then maybe we'll do Q&A at 8:05.
I mean, let me just finish maybe this slide, and then
that sounds good.
I'll stop at that point.
It's very good information.
Beautiful.
Thank you.
Yeah.
So let's talk the numbers. The last slide is about just numbers. With Señorita, users reached on average typing speed about 6 words per minute. And it might not sound super fast, lightning fast, definitely not. But for context, so you know it, most existing tools for blind users average between 1 to 3 words per minute. Can you believe it? I mean, people type at the level of 3 words per minute, and with huge amount of mistakes. So I guess this is kind of big leap forward for that area of research, because what really caught our attention, though, it wasn't just numbers, it's how people quickly learned our keyword. Blind participants picked up this chording thing, this pressing 2 keys simultaneously together, surprisingly fast. Without relying on sight, they started build, some kind of muscle memory for the key combinations. So after just few sessions, their thumbs, they knew where to put their thumbs. They didn't need to listen the letters, they didn't need, the audio feedback at all, because they started playing with their thumbs on our keyboard as if they're playing some, piano, or some other instrument. And that's their feedback was as well as supported this statement, because they said that our keyboard was very playful. And after just few sessions, their thumbs were going like this. They didn't rely on visual feedback, right? And the other thing that we observed is that participants who had some kind of low vision, light perception, on the other hand, they often tried to rely on they still relied on their visual or audio cues, they tried to see, some patterns maybe, which actually slowed them down, because instead of relying on their muscle memory, they tried to, listen to some letters and try to find them. Yeah, so it's a great example of how designing around people's strengths, I guess, not their limitation, can lead to surprisingly positive results. And I had another project that I wanted to discuss, but I don't think I have time. Yeah, so that's pretty much it. Let me just go and run to the last slide. Oops. Yeah, that's pretty much it. I guess I ran out of time. So if you guys have any questions, I'm here to answer.
So there are questions in the Q&A here, the chat.
Okay.
From Martin, excellent project for the blind. Did it need any approvals at the national level? How much has Señorita been distributed to the public?
That's a really great question. Thank you very much. So Yes, in our field, in human-computer interaction, we always get the IRB approval, first of all, because we work with humans. And, you know, when you work with humans, and especially since we work with blind people and low vision people and people with motor impairments, that's extra cautious, goes through extra round of, you know, I don't know, procedure checking process, I would say. And of course it's controlled. Whenever like we did our user studies, it was in controlled lab settings with people who observed the user study, and everything was recorded and stored in secure drives. So yeah, basically it was really hard to get that approval. And well, it makes sense, right? And regarding the second part of the question, the distribution, I wanted to upload it to Android and iOS platforms immediately because it's my, you know, PhD project. It's my baby project. I developed it since the first. The idea and everything is mine. So I was really, I was passionate to like really go and distribute it into all the platforms that we have. But then after discussion with my professor, ex-professor, past professor, we decided that we elaborate a little bit in that area. We are still working on that project and we're adding more things. And we decided that we're gonna.
I am so sorry to
make it.
interrupt. I have to leave though. It's 8 o'clock. Are we still going to get credit for being here? I'm sorry. I can't stay past any longer. I've been in school since 9 o'clock this morning.
Claudia, why don't you check with your professor, please?
Okay, thank you so much.
Thank you. All right, bye. Go ahead, Dr. Goldner. I
apologize. So yeah, I mean, like, I hope I answered your question. Yeah, we are still working on the project. We're adding more stuff, more features.
Any more questions? Maybe one more. A lot of great feedback here in the chat, Dr. Rahmatullah. Thank you so much for a wonderful presentation, a great topic, and congratulations for the achievements. We'll just have a break. Anybody else before we close the session?
I just want to say this was an absolutely amazing presentation.
Yeah.
The information was interesting, and I think that you are onto something. Congratulations.
Thank you. Thank you so much.
Thank you. Yeah. You're a rock
I
star.
wish I could share more because I have a bunch of projects in that area, and yeah, I just couldn't. This technical thing just glitched, and then yeah, but yeah, that's fine.
We do have some questions. If I mean, Dr. Hannah, I don't mind if they want to ask a couple of quick questions.
Sure.
Because I know they're going to go on the break, but if they want to ask her instead of break or before break, I don't have a problem with it.
Absolutely. See Archie and I don't know, Rahul has his
yeah.
Here you go.
Oh, I thought I'm the only one, so I just started to ask the question. Sorry about that. So I have a personal experience that I actually had a roommate who was blind, and I lived with him for about one and a half months. And I saw him actually use the talkback feature on the phone with 2x speed. I couldn't understand even a thing, but he was able to communicate. He was able to send message, and even so I had to transfer him some money, but the only way for him to know if the money has come in through his app or through his message was to read it out loud, talk back. So my personal experience of seeing them how they used it, they didn't have that. Means he actually did not have that much problem with the accuracy part of it, and I felt that this was eight years ago. So the technology must have come a lot more lot more ahead in that sense with accessibility. So my question is rather that, do you think any new technology with the addition of maybe AI has actually helped out a bit in like alleviating some of the errors or some of the issues in terms of accessibility, or is it a problem which does not need or does not get help from the addition of AI at all?
Well, I guess the talkback thing, the error prone of it, the error proneness of it depends on the human input. So how fluent a person is with this technology, right? If he can, I mean, like, but it's still slow. It's still slow. No matter how error prone it is, maybe less error prone for particular that user, it's still slow. Believe me, because people still need to swipe over the keyboard to
Yeah,
enter some kind of
that is true.
letter. And
That's
just
true.
imagine yourself if you want to try to enter some. And emojis part is crazy for blind people because when they enter emoji and they talk back like smiling face, smiling face, smiling face. Can you imagine that reading, like
Yeah,
writing the
yeah,
message and then hearing all this kind of it? I mean, like, it's
yeah,
really
yeah, yeah,
frustrating if you think
yeah,
about it.
yeah.
And they don't have other features, right? They don't have other options. That's why they stuck with it. They have to use it. They have to become fluent with this because big companies, they are not thinking about the accessibility aspect. They just starting to switch to add some accessibility features, but from the start, they didn't think about it, right? And imagine like even switching to these touchscreen devices. It's the nightmare for blind people, right? Because before with buttoned keyboard, blind people could locate their fingers on these keyboards and had some physical reference and had some physical feedback, right? When you push the button, it's kind of even the blind typing, you can do it on these keyboards, right? On physical keyboards. With these touchscreen keyboards, you can't do anything. I mean, like you do not feel anything. Everywhere is the same. How are you supposed to know where is the key? And imagine how blind people interact with it. Whenever we switched to touch screens, everyone was happy, but how about the other people? How about the blind people? No one thought about them, right? And we're just starting to think about it. We're trying to adapt this technology to blind people, but we didn't think about them when we switched to this technology, right? And I mean, like, there's huge gap in this accessibility, and we still need to work on that area. Yeah, and I guess I was answering your first question and I lost your second question. I
No,
get too
that's okay.
passionate. I'm sorry.
No, I totally like understand. After living with that person, I also felt a lot of I felt bad that the way that they were communicating, but back then I had no ways to help or improve it. But nowadays
Yeah, basically,
in
yeah, I mean, like switching from buttoned phones to touch screens was really great for us, for people who can see, but for those who are blind, it's a nightmare. Because before with button keyboard, it was easier for them to locate their fingers, but now, no, nothing.
true, true, true. And one of the ways where we can solve this issue of accessibility, at least with the blind people, is that we have a lot of new things coming up with AI integration. Like
Mhm.
we had R1 Rabbit, which was kind of connected to internet, but it did not have a screen at all. It had one button and it would talk back all of the information that it gathers from apps and everything as part of an
Mhm.
AI conversation. And similar things are being developed
Raquel?
as part of system with OpenAI and others.